Hello, good evening, everybody, or whatever time it is in the time zone that you're in. My name's David Griggs. I'm the president of RMetS, and welcome to this virtual meeting on Nature's Calendar, Recording Phenology in the UK by Professor Tim Sparks. I'll just run through a few housekeeping things before we start. So if we could move through to the next slide. Just to remind you, you can register to be part of the Weather Club. You can get full access to the Weather Club website, information about events and meetings, opportunities to participate in activities, including the Great British Weather Experiment and competitions. And obviously you get access to speak to experts about the weather. It comes with a full quarterly newsletter with weather news, stories and features. And of course, I hope you're all RMetS members. If you're not, then obviously we'd like you to become a member. Anyone interested involved in meteorology or climate change can join the society. Our membership is made up of professionals, enthusiasts, academics, students and teachers. There's a list of benefits there. You're joining a community of like-minded people with an interest in weather and climate. You can support our charitable activities, such as our education and outreach programs. You will obviously receive our monthly weather magazine. You get discounts at our conferences and paid-for meetings. You get discounts on our journals, including a new journal on climate resilience and sustainability. You get access to grants and obviously discounts at the RMetS shop. As you're all aware, we're using Demio for this presentation. The recommended browsers, I presume you've already on one of these, otherwise you wouldn't be here. That's Chrome, Firefox, Safari and Edge. To make your PowerPoint slides bigger, you can click the little sort of bottom right to top left arrows to enlarge the screen. You can close the chat by using the little one that has a vertical line with a left pointing arrow. And questions for speakers, you can point those into the chat box at any time, but we won't be answering questions until the presentation is complete. And finally, some upcoming talks. If you enjoy this one, we have a virtual meeting on air quality and health impacts of the Saddleworth Moor and Australian wildfires by Ailish Graham on Thursday, the 10th of December. And then on Wednesday, the 16th of December, we have a meeting on 100 years of meteorology at Imperial College. So I think that's all of the housekeeping. So now we'll move into the presentation by Professor Tim Sparks. I'm delighted to be able to say that Tim is joining us. He's got a background in applying quantitative techniques to biological data. He says he tends to get distracted and has a fascination for idiosyncratic, historical or long-term data sets that can provide information about environmental change. Apparently he's got far too many of these already, but that's not stopping him to collecting even more. He's previously worked at various UK research institutes and universities, and for universities in both Poland and Germany. He currently has affiliations with Poznan University of Life Sciences and the Universities of Liverpool and Cambridge. He's an editor of the journal Climate Research and serves on the editorial boards of other journals. He established a phenological network in the UK in 1998, which is now run by the Woodland Trust as Nature's Calendar, and he acts as in a voluntary capacity for the Trust. So Tim, I'll hand over to you for your presentation. You've got 45 minutes and I'm looking forward to hearing what you've got to say.
Thank you very much, Dave. Well, I've got some slides for you. My big dilemma really was what not to include. So there's lots of slides that I'd love to have shared with you, but I don't have the time to include all of those and introduce you to some of the fascinating characters that have been involved with phenology over the years. So phenology, for those of you that may not know, is the study of the timing of natural events, particularly in relation to climate. What I'm going to do is talk a little bit about changes, then something about the history of phenology in the UK and some more recent examples. And I'm going to surely run out of time before we get to the end, and the chairman's going to cut me short somewhere, and I'm going to have to cut short some of my slides towards the end. My title slide, I've got two title slides. This is the first of them, includes a picture of a dandelion. And the reason that I've got a picture of a dandelion here is that some of our continental Europe colleagues want us to record the first dandelion of spring. And the problem in the UK is that dandelion can be seen in flower in every month of the year. And this is a January dandelion, just to prove that it doesn't have a distinct, very obvious spring flowering date. So let's move on. When I was at primary school, we learnt this poem by Thomas Hood. He wrote this about, what's this, getting on for 180 years ago now. And I always thought it was a nice poem. And it seemed to sum up how Novembers were when I was at primary school. And just those last few lines, which talk about no butterflies, no bees, no fruits, no flowers, no leaves, no birds, it summarizes how bleak and miserable Novembers really were. You know, a fairly awful month. And we've just finished November, we've just clicked over into December. And so maybe it's time to just look at what the weather was like, what Novembers were actually like when Thomas Hood wrote this poem. So I've taken the Central England temperatures for the 30 years ending in 1844 and the 30 most recent complete years, just to do a comparison. And this shows you the big difference there has been. On the left-hand side, the temperatures in November that Thomas Hood would have experienced. On the right-hand side, the most recent 30 years. And there's been almost a regime shift here. November is now very much warmer than it was when Thomas Hood wrote those words about how bleak and miserable Novembers actually were. And if we go beyond November and look at the whole year, the blue bars here show the mean Central England temperatures for Thomas Hood's 30-year period. The red solid line is the most recent complete set of 30 years, and the dotted line is what we've seen so far for 2020. And in every month of the year, it is now warmer than it was when Thomas Hood wrote that poem. And it's interesting, there are certain facts. On the left-hand side, you can see that the January temperature now, the solid red line, is warmer than February temperatures in Hood's day, and not far short of March temperatures. And in fact, the 2020 January temperature at about 6 point something degrees was warmer than a typical March in Thomas Hood's day. So there has been considerable changes in our environment, and that's had knock-on effects, as we shall see in a minute as I progress through some of these slides. I'm particularly fascinated in phenology because I think it gives us a vehicle to convey the fact that the environment, our environment, is changing, and it's changing quite rapidly. So we can show slides that demonstrate changes in temperature, and this just happens to be the long-term record from Sheffield, which I think is the Botanic Garden. And we can see that there is a huge amount of variation from year to year. This is annual mean temperature. And that there is an underlying trend shown by the blue line of an increase in temperature. But this is very difficult to convey to the general public. You know, what does a 0.5 or a 0.7 degree rise in temperature actually mean? And sometimes it's much better to try and say what the impacts of these changes have been in terms that they can understand, that they're more familiar with. And as part of this, I'm looking at long-term changes. And one of the cruel things I do is I go through old documents like this, which are stuffed full of information, but need a lot of deciphering. And it's hard work, but it is quite rewarding in many cases. But sometimes we get that information in a more readily digestible form. And some of that information about how much things have changed comes from one of my heroes. This is Leonard Jennings, who was born, I think, on New Year's Day in 1800, and was a vicar near Cambridge for many years. And he wrote about the wildlife of the county of Cambridgeshire, which is where I'm based. And there are three species here: the red squirrel, the swallowtail butterfly, and the burbot, which is a freshwater relative of the cod. And he described these as common, found in the greatest plenty, and common. And the important fact is that these species, which Leonard Jennings hardly thought worth mentioning, are now all extinct in Cambridgeshire. And the burbot, the fish at the bottom, is now extinct throughout the UK. So there have been huge changes, and we need to document these so that we can inform people of the changes that have been taking place. This is my alternate title slide. And I must really get around to writing this up. Detecting climate change using Rhubarb, and Rhubarb is probably my personal contribution to phenology, and one which I'll probably be remembered for. And I'll come back to the story of Rhubarb in a minute. Spring is a very difficult concept. It means very different things to very different people. As meteorologists, you may think that spring starts on the 1st of March every single year, but that's not a widely held view. That there's often a general consensus that spring is something biological, but it's marked in different ways. So some people, look out for daffodils. Some people look out for the return of migrant birds like the swallow, and other people eagerly wait the completion of roadworks, which are promised at some vague date in the spring. But the date is not particularly well defined. So spring is a very personal concept. One thing that is very obvious, and these are some photographs that I've been taking in Cambridge over the last 10 years or so, is that there is quite remarkable differences between springs of different years, even sometimes successive years. And I'll just draw your attention to on the top line, the year 2011, which is just left of center on the top, probably the earliest spring that we've had on record, quite remarkable, and 2013 in the far top right. Of cold late spring, and just try and remember 2011 and 2013 as examples of early and late springs. This avenue of trees consists of lime trees and horse chestnuts, and it is very obvious when spring is coming if you classify spring according to these species. At the other end of the year, these are photographs taken roughly at the same day of the year over the last 20 years. And in fact, I went out this morning to take the one on the bottom right-hand corner. I thought I'd try and sneak that into today's presentation, and as a reward, I got caught up in 2 road closures and when downloading the photographs, a complete USB failure. So, but eventually we've got that photograph on the bottom right there. So we have a series of photographs of autumn, and you can see again there are considerable variation in in the state of autumn from year to year. 2002 and 2003 on the top row, the trees were, if not completely, virtually bare, and there are some other years when on the same day of the year these oak trees are still remarkably green. I've now taken 20 years of these photographs, and I'm almost starting to believe that I can see a pattern, but that may be wishful thinking on my part. Certainly, that the bare years seem to occur closer to the beginning than towards the end. And fate doesn't always help. I was taking photographs of the same apple tree every 2 weeks over period of about 3 years in the end, and in the bottom right hand corner shows you what actually happened. So when you start what you think is going to be a long-term exercise in photographing subjects, things can happen that you can't foresee, and in this particular case the complete removal of that particular tree. And the reason that I was interested is in the top left hand corner we have a photograph towards the end of November in 2005, which shows remarkable levels of leaves still on the tree. And even in the middle right, 5th of November 2006, again late in the year, but still remarkable levels of leaves on the tree. Of course, that's no longer recordable. I do need to be cautious whenever I talk about the effects of climate change, and I use this example from 1933, which was wondering whether all of the unseasonal, I suppose, flaring of events was actually pointing towards something in the way of a climate change. So I never rely on the results from a single year, and I do like to see long-term records to convince myself and others that this is in fact part of a longer term trend, and preferably demonstrate a relationship with temperature as well. Rhubarb. I promised you rhubarb, and this is my contribution. In my family, a crumble on a Sunday is a very traditional sort of thing, and the rhubarb crumble is the first crumble of the year, and this data is collected in a completely unscientific way. It involves me wandering down the garden and deciding whether there is enough rhubarb to fill the pot or not. And it's as simple as that. I don't measure the petiole width or length or the volume or the biomass or anything. It's just a visual interpretation. Is there enough rhubarb? If there is, it gets picked and a crumble is made. Just like to point out a couple of things. Top left-hand corner, 2013, that very cold year that I showed you the photograph of earlier, was in fact the latest rhubarb crumble within this series. And down in the bottom right hand corner, 2011, probably the earliest spring we've got on record. What I've done with these records is I've plotted them here against the mean temperature for February, and there is a relationship there. So that this shouldn't surprise us at all, because if it wasn't the case, we wouldn't bother with greenhouses. So that in the warm years, vegetation occurs early, and in the cold years, vegetation occurs late. So that's rhubarb crumble, my contribution to science, and quite a nice relationship. But I've gone one step further. In blue here are my rhubarb crumble dates, and I've actually matched these with two other series of rhubarb that I've been able to get hold of. The first of these in the top right, the dashed line on the top right hand side there, is a Victorian record from the top left hand corner of Ireland in Donegal, collected by a vicar in, I think, the 1860s. And the dotted line on the left hand side are harvesting records more recently from Poland. And you can see that there are strong temperature relationships from different countries, from different eras, and collected in different ways and for different purposes. Now, the history of phenology, it's a very long thing. We need to go back about 2,300 years ago, and the ancient Greeks were collecting records of when events started to occur. So Theophrastus here was collecting data on migrant birds and on flowers and on trees, and that's quite an eye-opener when we look at it in a British perspective, that, you know, what were Britons doing 2,300 years ago? Almost certainly not collecting phenology. There were some records towards the end of the 17th century, but the person that we most associate with British phenology is this character called Robert Marsham, who was another one of my heroes. There are several heroes I'm going to introduce you to today. Robert Marsham lived just north of Norwich, and in 1736 he started to record 27 indications of spring. He continued those until his death in 1797, and quite remarkably, his records were then continued by successive generations of his family right down until 1958, when person or persons unknown told the family that their records were no longer wanted. But he was a very determined, almost obsessive character who recorded events year after year, principally because he was interested in the production of trees on a commercial basis. And if we just take Robert Marsham's 60-odd years of records of oak leafing. So this is Robert Marsham. And we plot them against the February, March, April mean Central England temperature. We get this really nice relationship. You'll notice it's much better than my own rhubarb relationship. It's a much stronger relationship. And what that relationship tells us is that roughly for every 1 degree Celsius that it gets warmer, that oak leafing will come out maybe 6 or 8 days earlier in the spring. And that is a remarkable relationship. That's his own records. And if we add on the records of his son and grandson and then other generations, we can build up a fascinating picture of how trees have responded to temperature over 2 centuries. Now, the Royal Met Society got involved with coordinating a scheme with a consortium of other organisations in 1875. And that survived until 1947. In 1947, the Royal Met Society weren't quite sure why they were collecting information on flowers and moths, for example. You know, was that the role of a meteorological society? And they tried to find someone to take over this scheme. And sadly, no one seemed to be willing at that time to take it on, and the National Recording Scheme lapsed. It did get to about 600 recorders at its maximum. Its format changed at various times as different organisers came on board. They had different interests. So the last of the organisers, Major Gunton, was particularly interested in moths. So for the last 12 years of the scheme, there's a lot of moth recording included in the scheme, for example. But this is brilliant, and it provides a massive data, quite a massive data over that 70-year period. But even the creation of the scheme in 1875 was quite fascinating and had a much longer history than you might imagine, because it took almost 30 years for that scheme to get going. And we have to go back to 1841 when the Belgian mathematician Quetelet had gone to the British Association meeting in Plymouth and had asked for phenology to be recorded as part of national statistics. And the British set up a committee to look into this, and it took them 4 years to report back, and they came back in 1845, and they had a list of plants, fish, mammals, and invertebrates they thought it would be worth recording. And it was overly ambitious, so that there was a botanist involved in plants, and he suggested that several hundred plant species could be monitored, and it was obviously far too ambitious for its day. And this went backwards and forwards between various committees, and then it really wasn't until the Royal Meteorological Society took hold of this and formed a scheme that it really got underway. And I say the Royal Met Society, and I just need to make sure, and someone will correct me later, was it royal in 1875, or did it get the royal title slightly after that? Someone will correct me, I'm sure. This is the last of those reports from 1847. It shows the song thrush singing and hazel catkins. And these were latterly published. And these exist in each of the quarterly journals from 1875. And we've been incredibly lucky, and we have digitized all of the data, and it's on the Woodland Trust's Nature's Calendar database, so that we can make comparisons between the older data and the current data. This is just one example from that scheme. This is ivy flowering, which is an autumn event. If you're not familiar with the flowers of ivy, I strongly suggest you go and look at them, because it is a remarkably pretty flower for something that's green and not very conspicuous. And you can see here the records of ivy first flowering in the autumn plotted against April, May, June mean temperature when the buds will be developing. And again, there's a strong temperature relationship. And a slightly different record. This is the flowering dates of garlic mustard, the solid black symbols on the bottom, and the first appearance of orange tip butterfly at the top as the open circles. And you can see the underlying pattern with temperature is possibly not linear, not a straight line, but it's perhaps a little bit flat on the left where it's cold, and then it gets a bit steeper, and then it may become rather flat again. And the important thing about these two species is that garlic mustard is one of the two flower species that orange tip caterpillars feed on. And so it's important that these two remain synchronized with one another. So if they change at different rates, then there's potentially a mismatch here, and that one or other of the species may suffer as a consequence. So we're particularly interested in synchrony, and particularly interested in non-linear relationships with temperature. During that scheme, during the Royal Meteorological Society scheme, 1875 to 1947, there are some fascinating individuals that were involved in recording, and some of those were recording for 40 years or more. One of the amateur meteorologists was a John Willis, who lived in Norwich. His mother was a member of the Coleman family, so there was mustard money in the family. And he wrote a book which was published in 1944 called Weatherwise. And I find this a fascinating book because he went out on January the 1st each year and he took a photograph of the same bunch of snowdrops. On February the 1st, he went out and took a picture of the same bunch of daffodils, which is what these two photographs are. 1916 on the left, 1917 on the right, and he had to scrape away the snow in 1917 to confirm that there was no sign at that point of daffodils. On March the 1st, he went back, he photographed the daffodils again. On April the 1st, he went out and I think photographed a beech tree, and on May the 1st, a horse chestnut tree. So this little book contains these brilliant photographs, which have probably encouraged me to go out and do something quite similar. It did encourage a lot of other people in the Norwich area and possibly further afield to record phenology. That includes Mary Manning, who recorded things like aconite flowering in her garden for 40 years or more. And I found a review of John Willis's book, which I thought was quite a nice one. It criticizes the book because he titled it 30 Years of Weather in England, and it was actually based around his records in Norwich. But the reviewer said, Mr. Willis has adopted a literary style best described as flowery, which I think is quite a nice description of the book. It's a lovely little book. You can still pick it up quite cheaply in second-hand online shops or stores. So it's Weatherwise by John Willis. Since the Royal Meteorological scheme failed, there have been a number of individuals, important individuals, that have been recording. So these are Anne Hall's records from near Newcastle. Just working for her own amusement, for her own interest, she recorded the flowering dates of the 200 plant species that she could record for a period of 50 years and kept it on the card index system. Luckily, we managed to digitize all of these records because so many of these records are thrown away when that person passes on. Not everyone records on paper. This individual from Warwickshire records daffodil flowering dates on his garden shed. And if you think that's unusual, I can find several other examples where long-term records like this have all been kept, all been written on buildings. So on doors, on window frames, on lintels, that sort of thing. And there's quite a strange group of people that record physically on buildings. This is Jean Coombs. She's now 90 something, 90, 92, 93. This is her receiving her OBE at Buckingham Palace, a well-deserved OBE for her years of recording of tree phenology. And the important thing about Jean is that she has recorded trees since about 1947. This is her oak budburst data from 1950. It's the same tree throughout those years. So from 1950 onwards, you can see that there's great variation from year to year. The red line here is the underlying trend. It's now considerably earlier, possibly 3 weeks earlier than it was back in the 1950s. Since about the late 80s or the 1990s, there's been a rash of budburst dates around the end of March, beginning of April. And there have been very few in that same period, very few records in late April and in May. And it's a really powerful set of data to show changes. This is based in her village in Surrey. And it's a remarkable series that we hope is going to continue for many more years. Further afield, there's some excellent records. This is from Geneva. This is the budburst of horse chestnut. It's a record that's existed from about 1808, and the Swiss Meteorological Organization record a number of these very long-term records. So there are some long-term cherry records as well as this horse chestnut record. And the red line there shows the underlying trend. And again, you can see there's been a considerable change, a trend towards much earlier budburst than there was in earlier years. And the record-breaking one must go to Japan and to the Kyoto, the former capital, and records of cherry flowering, which have existed since about 705 AD. And from about the time of the Norman conquest, there are enough data to look at the underlying pattern, which is the solid line in the middle there. It's a remarkable series because you can detect big volcanic events which have slowed spring right down or blotted out the sun for several months. And in the circle there on the right hand side, you can see there's quite a considerable advance in flowering in the most recent time period. So there are lots of such records from around the world, focused probably in the Northern Hemisphere simply because there's more land mass and more people recording in the Northern Hemisphere. This is some work I'm doing with Russian colleagues, quite a long way inland. This is towards the eastern limit of Europe, several hundred kilometers east of Moscow. And we thought for a long time that the response to temperature in Russian phenology was very flat. There was hardly any response compared to what we see in the UK. But recently, we've had some record-breaking springs in Russia, including March 2020, which I think was the warmest for 200 years. And what seems to have happened is that we can see evidence of a temperature relationship, which is what we call a broken stick. So that it's fairly flat up to about 7 degrees Celsius. And beyond that, it's much steeper. So the black line here would be a straight line relationship. It's not very realistic in this situation. And the solid gray line is in fact this broken stick model, which would seem to suggest that there has been a rapid advance in phenology, temperatures above 7 degrees Celsius. And it was only those very cold Russian springs that kept things particularly late. So we may see some very rapid changes in Russia in the future. Going back to my earlier hero, Leonard Jennings, I perhaps forgot to mention the fact that someone asked him to be the scientist on the Beagle, and he said no, he didn't have time because he was too busy being a vicar and looking after his parishioners, and perhaps his student Darwin could go in his place. But that's a completely another story that's going to have to wait for another time. he did warn us, and it's quite right, that we can't record birds and insects with the same level of accuracy as we can with plants. So in terms of plant flowering and tree leafing, we know where that plant is going to occur. We can regularly monitor it. With birds and insects, we have some idea where they will occur, but we can't be so very exact. But what does surprise me is that despite that, and despite the fact that we can have very independent recorders, we can sometimes get remarkable consistency. Now, this graph is quite old now, but it does show remarkable consistency between 4 recorders, and all showing a trend towards much earlier appearance of the orange-tipped butterfly. And those 4 recorders are Richard Harrington, who has recently retired from being in charge of the insect survey at Rothamsted, Anne Phillips, who recorded mostly in her garden in Walsall. Sorry, Rothamsted is in Hertfordshire, for those that don't know it. John Clark was a farmer from Burwell in Cambridgeshire. And Owen Tudor, great name, very nice man, was someone who recorded a butterfly transact in the Wyre Forest in Worcestershire. And despite the fact that these 4 individuals recorded in different ways, in different environments, and never met and conversed, you get this remarkable degree of accuracy. Consistency, rather. And we still need to convince people that change is taking place and that we need to take some action about it. And photographs can be really powerful in this respect. So fixed point photographs that show big changes can be quite dramatic. So this is a glacier in Alaska, taken on different, I think in the 1940s and the early 2000s, showing how far these glaciers had retreated in that time. But the only problem with such images is that Alaska's a long way away, and that doesn't really affect us very much. So we do need to start thinking local for examples of change. And there are lots of examples closer to home that we can use. So for example, here we have the cenotaph. The picture on the left is the early 1920s on November the 11th, and the picture on the right is November the 11th this year. What I'd like to draw your attention to is not the cenotaph, not the height of the flower memorial, which is if on the left-hand side, you may just be able to make out a guard. And so the flowers are the same height as the guard, but the trees in the background. These trees are all London plains. And I think we haven't yet really exploited photographs in the way that we really could to demonstrate change. So there are lots of photographs out there. There's events like May Day in Oxford. Around the world, we remember on November the 11th, and in Australia and New Zealand, Anzac Day is also incredibly popular. And all of these events will be associated with photographs year on year. So there's a great resource there that we should really be exploiting much more than we are at the moment to demonstrate really how much change there has been. And in terms of the cenotaph here in London, sorry, not here in London because I'm in Cambridge, in terms of the cenotaph here in the UK, remarkable change. Trees back in the 1920s and 30s were remarkably bare. You see the royal family wrapped up in very thick coats on balconies. And in more recent time, we've had these remarkably green years, and the trees are all London plains. We get the same story if we look at Paris on the Champs-Élysées, same species of tree, same overall pattern. And we've got other sources of data we can now exploit. This is Harvard Forest in New England. This is a webcam. It does allow us to see on a daily or sub-daily basis how the vegetation is changing, and we can identify the species that are involved. It's probably more flexible really than satellite imagery, where satellite imagery can measure greenness over a large area, but it can't really tell us very much about what species are involved. So they are very different beasts, webcam images and satellite images. But with many of them now, we can convert the images to red, green, blue frequencies and analyze them appropriately. And other sources of information include long-term records that we can glean from collections. So herbarium, collections of plants. The plants themselves are often associated with a location and a date, such as the one on the left, and the same with insects in museums. They're often associated with where they were collected and on what date they were collected. And it's remarkable how many of these show a very strong climate signal. This is the village of Triplow, which is between Cambridge and Royston. And I've included some information from here because it just shows how much our society is learning to adapt to a changing climate. Each year, Triplow holds a flower festival weekend. It's been doing it since 1969. It attracts about 10,000 people each year. The money goes to charity. It's a very important thing. It sadly had to postpone it during the foot and mouth outbreak in, I think, 2004. But it also had to cancel the 2019 event, and it's already sadly cancelled the 2020 event this spring. It had to cancel, and it's already cancelled the 2021 event for next spring because of problems with COVID and the inability to safely host that many people. But what we have here is the date of the Saturday of those weekends since 1969. And you can see that the organisers of this event, because the event is decided 18 months in advance, have had to progressively shift the flower festival earlier and earlier in the year because the daffodils are becoming so much earlier. They have adapted their own style. They have planted a much wider range of daffodils to try and even out the problems of a very variable climate. But even so, that's a remarkable change in behavior to try and accommodate the influence of climate on the flowering of daffodils. Finally, and in the next few slides, I'd like to talk about Nature's Calendar. Nature's Calendar is a scheme which is coordinated by the Woodland Trust and has been for over 20 years now. It's a UK-wide scheme, and it was revived in 1998. So the intention was that it looked something like the Royal Meteorological Society scheme, and that it had some common elements, but also had some slightly different elements. It contains a spring scheme and an autumn scheme as separate entities, and it is generally asking for people to record simple events of fairly common and widespread species. There are one or two exceptions, but that's the rationale behind it. So not the 1845 request to record, several hundred plant species, but a much more limited number of more easily identifiable species. Recording is online for our oldest recorders, our longest serving recorders rather. We still offer some paper-based recording, but for new recorders, it's exclusively online. And we've added older records to the database. So the Royal Meteorological Society data is added. The British Naturalists Association data is added. Various individuals like Jean Coombs and Anne Hall and Richard Fitter, the data have been added. And now the database contains over 3 million records. And I would encourage you all, if you're not already taking part in this scheme, or if you know people that would be interested in taking part, to actually go and have a look at the website and take part from next spring. I guess would be the best time to start. I think this would be a wonderful scheme. I've always thought this would be a wonderful scheme for dog walkers, because dog walkers often walk the same route day after day, and it's those people that need to to do something else other than walk their dog and look a bit mournful. Recording the way that the world around them is changing on a day-to-day basis would be a wonderful distraction from walking a wet and smelly dog on a miserable day. Perhaps not all dogs are wet and smelly, but on a very wet day. There's a range of species and events to record that includes plants as well as insects. It includes some amphibian records and birds, and a fungal record as well. So there's a range of things there. No one is expected to record everything, which is quite an important thing to remember. So not everyone is expected to record every single event, and anything that can be contributed is welcomed. There's a whole host of things here, so this just shows some of them for some of the plants. So for hawthorn, for example, people are asked for first bud burst, first leafing, first flowering, first ripe fruit, first autumn tinting, full tinting, the beginning of leaves falling, and the shrub being bare at the end of the year. So generally speaking, these are not difficult things to record, but we still have a dominance of spring records. Spring is always much more popular than autumn, and I think that's something to do with the way that we're looking forward to spring and perhaps less looking forward to winter. I need to hurry up a little bit because the chairman has just come on and given me my warning. Nature's calendar, we record a spring index. We've generated a spring index which is used by UK government, and it's always been intended to be a simple event, a simple index. It's really the mean of first flowering of hawthorn and of horse chestnut, the first appearance of the orange-tipped butterfly, and the first sighting of swallow. And what we've chosen these species because they were also recorded by the Royal Meteorological Society. So we can combine on the left here the records recorded by the Royal Meteorological Society with the more recent 20 years of records under Nature's calendar. And from those records, we can see there's been a shift of about 8 days between those two broad periods. And you can see that sadly, between 1947 and 1998, we don't have enough data to generate an index, because that's this period when there was no national recording scheme, sadly. All of the data, when it's submitted, instantly appears on the live maps on the Nature's Calendar website, and these can be played like videos, and they can be compared with one another. So this particular one shows swift records on 3 different dates of the year, and you can move the bar at the bottom to progress or reverse the season to see where records appear and on what dates. And the data is increasingly being used by government and individuals for research purposes. And the data has achieved maturity now. The data has really become useful. So for many years, we were thinking, I hope for another spring and some more data, and we want more data. We've now got that quantity of data that makes this a really useful data set in its own right. So this is just one of those. Martin Baker, Cambridgeshire, horse chestnut flowering records against temperature. And you can see a remarkable relationship there. And this is typical of many of these events. They really are very strongly driven by climate. I'm not going to talk about this one because I've really not got time, but it was really some work we did to try and see whether we could get a better handle on growing seasons by taking biological records rather than the more familiar one that's based on temperature. So the one that's based on temperature sometimes, but not always, takes account of cold spells that occur after a warm spell. And some of these growing season records for the UK effectively end up as 365 days, because we have temperatures above 5 degrees in January and temperatures above 5 degrees in December. So it was intended as a slight criticism of basing growing season purely on temperature records and not on the biological records, which I think might be more appropriate. I mentioned before Synchrony. That's going to be an issue. We need to try and find out where things are going to pose a problem. So this is 2 fungal species. One is parasitic on the other, but is totally reliant on one other species. And if they don't synchronize, there is an issue. And my final slide is to try and summarize what I've said today. I apologize, I've had to leave out so many examples from so many fascinating recorders. There is a long history in the UK and more widely. The Royal Meteorological Society generated a considerable body of data, which we've now incorporated into the Nature's Calendar database, and that's proving very useful in comparisons with modern data. Change has been very evident, particularly in spring, across a wide range of events: flowering, leafing, amphibians, birds, insects. A wide range of things have been getting earlier in spring. But we are totally dependent on volunteer recorders, who we're incredibly grateful for. We'd love to have too many that we can't cope. So more recorders, yes please, everyone that you can think of that is willing to contribute one or many hundred records would be welcome. And that scheme is now at a level of maturity that makes it incredibly useful in its own right. And we do need to carry on this work, because it is very essential that we are prepared for changes that will happen in the future. Thank you.
Fascinating. And we'll move now to questions, and there are lots of questions in the chat. Fortunately, Lori-Ann Whittle has been going through and answering some of the questions, so apologies if I don't get through to all of the questions, but I hope some of you have at least had your questions answered already. The first one to pass through to you, Tim, is there any data about the arrival of the first cuckoo? Is that any good for giving clues about climate in Britain or over wider Europe? Is the cuckoo a good indicator?
A cuckoo, Robert Marsham started recording cuckoo in 1736, and I think there are some records from 1695 as well. So there are long-term records of the cuckoo. One of the problems with it is that it is in serious decline, and very many people no longer hear it. So we have done some work, again, using the Royal Meteorological Society records that show the decline in cuckoo relative to other species by the absence of records. I myself very rarely hear the cuckoo now, and I think it is becoming more problematic. So there are better species than cuckoo, but it's still very much seen as a spring icon. I should point out that Lori-Ann Whittle is one of the Nature's Calendar team, one of the two brilliant people, Lori-Ann and Judith, who manage the Nature's Calendar scheme at the Woodland Trust. So her answers are perfectly legitimate, and hopefully she's reduced the amount of work that I've got to do.
Well, I think she's already answered the next question, which is, do you have a graph of ash leafing compared with that of oak? So perhaps we'll pass over.
Yeah, we have, because Jean Coombs records both of them. And if you're going to ask me about ash before oak in for a soak, no, there's no evidence that there's any relationship there whatsoever.
Okay, so the next one is, you've answered this a little bit because you have talked about synchrony, but there's a part at the end here. Have you seen a subsequent response by the animal world to the growth in changes? And could you comment on the lag time?
In the case of insects, it's almost instantaneous, because insects are essentially little solar panels. You know, they're cold-blooded, so they need warmth in order to grow and develop. And so for insects, the response is almost immediate. So that early events in spring will be triggered by warm springs, and there isn't a lag period. For mammals and for larger birds, there's less evidence of a lag effect. I think there may have been one or two studies that show an effect the following year. But bird nesting, bird migration have all shown responses to the temperature of that year. So for some of the migrant birds and for some of the nesting birds, we can show a response to that year's weather rather than previous years. It's much harder to look at lag effects over years.
Okay, so the next question is, isn't there a phenological garden at the Valencia Observatory in Southwest Ireland?
Yeah, there's a scheme called the International Phenological Gardens, which I think got established in the late 1950s when it was based around, it's based around a university in Berlin now, who sent cloned plant material around different gardens around Europe to record. So they've got clone material. They're all recording identical plant material in very different locations. So I think there's actually 4 in Ireland, and there's places in Portugal, and there's lots in Germany, and right throughout Europe. There's actually not very many in Britain. I think some have been established in more recent years, but yes, there is a phenological garden there. And I think before the Second World War, what used to be the Ministry of Agriculture also had some phenological gardens.
Thank you. And just a note, that's the Royal Metsoc have posted that the RMetS became royal in 1883.
Yeah, I was suspicious that I'd written Royal Met Society in 1875 and it wasn't. Yeah.
We'll take it. The next question is, there were questions about Apple phenological data, but Lorianne has answered those. So we'll pass on to this one. And I like this one because it's one of the ones that I had prepared as well. So many great examples of temperature effects, Tim. Thank you. Is there anything you can point to in terms of the effects of trends in other climate variables, such as rainfall? And how do you pick apart the impact of temperature and rainfall in the phenological data?
Yeah, one of the issues with the UK is that we're never usually short of water. So, in spring, soil moisture is usually recovered, and we don't have droughts and drought stress that some other countries do get. So in spring, most of the events we see are driven by temperature. There is some suggestion, which we need to sort of spend more time on, that ash leafing may be more driven by sunshine than temperature, which is quite an interesting thing. And disentangling those two would be very difficult. If we go much further afield, in Arizona, for example, a lot of the flowering there is driven by rainfall. And in arid areas, flowering seasonality is driven by rainfall events rather than temperature events, because the temperature is already perfectly adequate for growth. What's lacking is water. So in different environments, rainfall is important. In the UK, much less so. Autumn is a problematic one because leaf yeah. Spring is very simple. High temperatures, early growth. In autumn, it could be a really complex combination of gales and the diurnal temperature range between daytime and nighttime temperatures and sharp frosts, and all of those things can combine to defoliate trees. So the autumn picture is more complex, and that's very worthy of disentangling. I think that would be a very nice piece of work to look at.
So the next question is, do we need a better link between meteorological observations with phenological observations? If so, how do you think we could do this?
We already, we're very lucky that we've got access to such good temperature records in this country. And the Hadley Centre at the Met Office make this Central England temperature widely available. And we've got daily minimums, maximums and means, as well as monthly data as well. So we have got lots of data there. The Central England temperature series is representative of quite a large part of the country. You have to go quite a long way away before it isn't really indicative of what the temperature or the climate was like at that time. It would really be nice to start investigating the role of soil temperature, for example, on plant growth. But I think you'd really need the Met station to be really close to the plants that you're monitoring, which is why the scheme, we talked about that scheme at Valentia in Ireland. Most of those phenological gardens were based around Met stations. So you could make that direct comparison. And that would make it, so much more powerful and give you many more opportunities to investigate soil temperatures and other aspects as well.
Okay, so then there have been a couple of comments which you may want to just address or just just to be aware of, that we've talked about links between the Met Office's weather observers. I might be able to hook those up to make phenological observations as well.
Yeah, I mean, all observers incredibly welcome. The horse chestnut question, yes, I spotted this in various locations this autumn. Quite remarkable, actually, because by then the trees had almost lost their leaves because of leaf miner defoliation. And what triggers that? I don't think we're really sure of. You sometimes do get second flowerings in autumn of things like apple trees and chestnuts and hawthorns. And I found some lovely literature from the 1920s written by a certain Francis Darwin, who was Charles Darwin's son and a reader of botany. And he recorded a couple of unusual years in the 1920s when these autumn flowering events had occurred. But we really don't have long-term data on it. That's the problem. Just one or two records here and there.
Okay, well, we're in danger of running over, so I'll take the chairman's privilege to ask one very quick last question, and then we'll have to stop. You showed a great picture of the same tree, or talked about the same tree being looked at the budding and the leafing over 50 years. Does the age of the tree have any impact on when it buds and leaves? You've got it was probably a sapling 50 years ago, and it's now an aging tree. So does that actually make a difference?
Yes, the age of the tree does have an effect, because if you imagine that you're a young tree in a woodland, you've got to try and get sunshine before your elders and the taller trees around you capture it. So very young saplings, very young trees tend to leaf out early. But Jean Coombs' oak tree was probably well over 100 years when she started recording it, maybe well over 200 years when she started recording it. And so by the time trees reach maturity, I don't think the age really has an influence.
Okay. Thank you very much, Tim.
Okay, you're very welcome.
That's been great. We're going to have to cut short here. I'm sorry about that. Hopefully we'll be able to keep the chat going for about 5 minutes after we close, so that you can chat amongst yourselves if you have anything you wish to post. Just a couple of final housekeeping slides from me. The talks will be published on YouTube and the RMetS website, and you can see the links there. And as just a reminder, there are 2 talks coming up on Thursday, the 10th of December, a virtual meeting on air quality and health impacts of the Saddleworth Moor and Australian wildfires. And then again on Wednesday, the 16th of December, on 100 years of meteorology at Imperial College. But by just thanking Tim once more for his excellent presentation, I'll close this, and I'll let the Society staff close the chat a little bit later. Thank you.